Here we have 9-1 day 1 after the video, and in a polar coordinate system, the origin is a fixed point O called the pole. The polar axis is an initial ray from the pole, usually horizontal and directed towards the right. Now, what that means is that we're going to use unit circle measurements to get the angles, and it says that the, what do they call it? The initial ray points to the right. The location of a point P in the polar coordinate system can be identified by polar coordinates of the form r and theta, where r is the radius of the circle and theta is the polar unit circle degree measurement, or it could be radians as well, where r is the indicated distance from the pole to the point and theta is a directed angle from the polar axis to P. So r is the distance from the pole, or we say the radius of the circle, and that's why it's r. To graph a point given in polar coordinates, remember that a positive value of theta indicates counterclockwise rotation from the polar axis, just like we do with unit circle measurements, while a negative value indicates a clockwise rotation. If r is positive, then P lies on the terminal side of theta, and if r is negative, P lies on the opposite direction of the angle, opposite the terminal side of theta. Graph each point. So let's graph a radius of -2 and an angle of 30. Well, let's go to 30, and I believe these are all 45. I think 45 is here. This is 30, and this would actually be 60 right here. So if we go to 230, this would be 230 degrees, and so -2, we just go in the opposite direction, 2. So this is actually point A right there. Point B is 4, but -120. So here's -90 and another 30, and then 1, 2, 3, 4 right there. This is point B. So we're just going -120 degrees. And then letter C is pi/6, but 4. So 1, 2, 3, 4, and of course this is pi/6. So this is letter C. Find 4 different pairs of polar coordinates that name point T if we're between -360 and 360. So this is, let's see, what degree is that? 15 degrees short of 180, so 165. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8. 8 and 165 degrees. We should also be able to get this with a -8. And that would be, let's see, -8. I would need -15 degrees. So -15 degrees. We should be able to get this with -8 in a positive angle. So I got to get over to here. So that's going to be all the way around 15 degrees short of 360. That's 345 degrees. So I have one positive. Let's see, I should be able to get, and then we have 2 with -8. We should be able to get 2 with +8. So now I just need to get to this angle right here, but going, how about in a negative direction? So we have 180 plus another 15 is 195 degrees. So there's 4 coordinates for the same point. Graph the polar equations. R equals 5. So we want all that we have to have is a radius of 5. Well, that's a circle. So 1, 2, 3, 4, 5, and it's, see how good of a circle I can draw. Just need to, it's this circle right here, and I probably could cheat and go, it's that circle right there. Graph the polar equations. Theta equals pi/4. So now we're looking at a line at pi/4. So let me do it like this. I can't go very far with this. I'm using a tablet and it's just not very big, so I don't have the ability to draw this very far, but I'll kind of cheat here. But here, if you have just theta equals something, that's a line. And it goes either direction because it doesn't give any restrictions on the radius. So the radius could be positive, the radius could be negative, and the radius could be 0. So you end up with this this line. and it's y equals x for pi over 4. Polar distance formula: if P is R1 theta 1 and P2 is R2 theta 2 are 2 points in the polar plane, then the distance P1 P2 is given by, this is actually comes from the law of cosines. So square the first r, square the last r, minus 2 R1 R2 cosine of the difference of the two angles. So find the distance. So the distance from A to B is equal to the square root of, all right, we're going to go 9 plus 100, and then minus 3 times 10, and then we need the cosine of theta 2 minus theta 1, so 124 minus 38. And then this is going to be a calculator problem, so square root of, oh, turn the calculator on, square root of 9 plus 100 minus 30 times the cosine of, I'll let the calculator do the work here, 124 minus 38. And before I hit enter, I'm going to mode, I'm in degrees, that's good. And we get about 10. So it's equal to 10.340 rounded. Find the distance between A and B, same thing. So from A to B is equal to the square root of 36 plus 16 minus 2 times 6 times 4 cosine of 11 pi over 12 minus pi over 3. So now we have to change our calculator to radians. Let's get out of there, and we'll go square root of 36 plus 16 minus 2 times 6 times 4, and then we got cosine of 11 pi divided by 12 minus pi divided by 3. All right, an 8.026. And everything after that is just review. So quick notes.